The Stanford business article, Americans eat fewer calories at restaurants if the calories of the food items are labeled on the menu. To investigate this, the researchers compared Starbucks receipts from locations where menus were labeled to receipts from stores where menus are not labeled. Random sample of 30 receipts from stores with the menus labeled had an average, so I'm going to start highlighting this a little bit. Random sample of 30 receipts labeled had an average number of calories of 225 calories, standard deviation of 100. And then a random sample from a store, of 40 receipts from stores without menus labeled, average of 265 with standard deviation of 75. All right. Does this provide convincing evidence that the average calories per receipt at Starbucks with a labeled menu is less than the Starbucks without the labeled menu? Lots of words, right? All right, so let's figure this out. Parameter. So you can come up with your own symbols. You just need to define them. All right. So I'm going to say mu of L, true mean calories at Starbucks with the labeled menu. And then mu of N would be the true, you can use ditto marks, mean calories at Starbucks without the labeled menu. You can use different letters, that's perfectly fine, just define it. All right, so the statistic, okay, X bar of the labeled was what, 225? X bar of the non-labeled was 265. Interesting. So now look at our hypothesis. I don't know how you want to phrase it, but what I usually do, just a personal preference, I'll say the mu of, they're going to be equal here, right? Labeled should equal non-labeled in the null. And the alternative, what is it saying? Is there convincing evidence the calories per menu at Starbucks with the labeled menu is less than the non-labeled? And what's our significance level? If they don't state it, it's 0.05, yes. So far, so good? Alrighty. Name the procedure. 2 sample t-test. Yeah? Alright, let's check our conditions. Were our samples random and independent? 2 different stores, right? So 2 random, independent samples. In this scenario, do we need to check 10%? Yes, this is an experiment? No, it's just observational. Good. 10% condition. So let's check the number of receipts. Okay, so the first one has 30 receipts. Is that less than 10% of all receipts? Yes. With the menu? That store with menu. And then the other one was 40. I think it's safe to say it's less than 10% of all receipts. Why does receipts have to be so hard to spell? At store without menu labeled. Okay. Okay, normal. CLT our friend here? Yes, it is. So we could just say 30 is greater than or equal to 30. So by CLT, we're good. 40 is greater than or equal to 30. So by CLT, we're good. Now, I'm not too concerned about you writing all this out, the mean, the standard deviation, the formulas, because that's just too much work. But I do want you to draw the picture, because what kind of test is this? Right-tailed, left-tailed, or two-tailed? It's a left-tailed test. This is kind of a built-in check for you, because whatever t value it generates for me, should it be positive or negative? Negative, right? It's on the left tail, right? If zero's in the middle, wouldn't that be negative? Okay, so what am I needing? You don't even have to write formulas. What am I showing for work? You're showing these values. So x bar L, S of the labeled, N of the labels was 30. Let's review what it said here. This was 225, and the standard deviation was 100. So x, oop, that's an N, that should be N, not labeled. 265. 75 standard deviation, and N of N was 40. All right, and I'm going to use my 2 sample t-test in my stat menu. So number 4. So t statistic is negative 1.34. The p-value is wait, something's wrong. What did I type in wrong? $225. Did y'all get that?
No. I got negative 1.84. Yeah, me too.
Yeah, I feel like I typed something in very wrong. Oh, yeah, my sample size was 10. That's not right. That did not sit right. Okay. 1.83 or 84? Okay, that sounds better. 1.84 and a p-value of 0.036, something like that. Now, the other thing you want to show for work is the degrees of freedom. Now, we have technology to do the gnarly equation I showed you in the video for that, so just use what the calculator gives you. If you had no other option, you could just take the smaller of the 2 samples and subtract 1. All right, but the calculator does it for us, so easy peasy. But write it down for work, okay? Now we can do our conclusion. All right, so it's going to start off just like we've done before. So since 0.036, that is less than our alpha, right? What does that mean? We reject the null. Then do we have convincing evidence? If we reject the null, that means we have good evidence of the alternative, or good evidence that they're guilty, right? We have convincing evidence that, here, go back to my parameter statement, the true, let's see, how was it phrased up there? I'm just going to use what the problem says. The average calories per receipt at Starbucks with a labeled menu is less than a Starbucks without the labels. So I'm not creative when it comes to the wording. I just go back to that problem stem. There's some insurance in that, so don't be afraid to use it. We can do it, but I don't think you really want to. But let's just look at this for a second. Look, at the top here, it's just taking us through the state plan do conclude that we've just walked through with an example, okay? It's just it's showing you all the stuff. Now look at this example. Look how small this example is. Look at our sample size. What is that going to do to us? And if we had to run this test, if I made you do it, how would that change our process? We would have to draw out samples dot plots, wouldn't we? For both samples. Yes, that is what would have to happen if that was the case. I'm not going to make you do it, but I just want to make sure you register that, oh, small samples, you're going to have to do dot plots. Make sure they're clear. And when you refer to them, you say that both dot plots show no strong outliers or skewness. Okay? It's rare that you would have to do that, but if you did, you should have the tools to do it.